Okay, so I am supposed to, according to the recipe, take the first moment of the mass. First moment of the mass with respect to x, that is the sum over all the masses, m sub I, x sub I. How many masses I have in this case? Yeah, it's smeared out, okay? I want to make a continuum approximation, so I need to sum up by doing an integral. And there was much rejoicing. Yay. So in order to do the integral, this is the key point. I have to chop it up in bits where the integrand isn't changing over the whole bit. I can't just say, the whole mass is m. I could figure out the area, sort of, if I made up something for the length and something for the height. But I'm supposed to sum up multiplied by x, and x changes over the course of adding up all those masses. So what's the most general shape that I can carve this thing up into at constant, so that x is constant in the little chunk? Squares. Vertical squares that are long and skinny. Yeah, that's it. Yeah, squares like that. Okay, So let's say that the mass inside that little rectangle is dm, okay? It'll be infinitesimal if the width is infinitely narrow, and it needs to be infinitesimal because x is changing in that direction. So I have to carve it up in a narrow little slice. So how would I calculate dm, knowing that the plate has uniform mass distribution? So what does that mean? Yeah. Right. So it's equal according to per unit area. Exactly. So this plate has every little bit of it, same size area means the same amount of mass. There's a proportionality. We will use the symbol sigma to mean mass per unit area. In this problem, sigma is or is not a function of position? Is not, but in other problems, like on homework hypothetically, it may be a function of position. We will use sigma as the mass density when we're talking about mass per unit area, and we'll use different letters when it's per length or per volume, which I'll get to. Okay, so if I had sigma, which I could, sigma in this case would be equal to m over the whole area, whatever that is. And knowing sigma, how would I get dm? I would need to calculate the area of that strip, of that little rectangle. Are we good so far? Okay, so now it boils down to geometry. I have to get an expression for dA. Any volunteers? Suppose that I make the origin of x over here. So we'll say y goes that way and x goes that way. What can you tell me about the height of the strip compared to its value of x position?
It's proportional.
Do you agree that it's proportional? Directly proportional. That is to say, the height, the y value, is, give me a letter. F. Give me a better letter. K. Okay, fine. So the height is some constant. I don't necessarily care what it is, but it's proportional. Do we agree with that? That's what this straight line and that straight line are telling us. Okay, so therefore, how would I get dA? So wouldn't that be the whole height, which is y, times the thickness, which is dx? Okay, that's the way we do calculus. We don't worry about the little infinitesimal triangle at the top and at the bottom because the sides are sloped. So the area of this strip is y dx, and therefore the mass in the strip is equal to sigma y dx.